Today I'd like to show you how to write equations of geometric and arithmetic sequences given more than one data point on the sequence. So first we're going to look at the arithmetic, and we know this because it says two terms of an arithmetic sequence are the fifth one, which is 10, and the 30th one, which is 110. So I first like to make a picture. My first term I don't know, my second term I don't know, third I don't know, fourth I don't know, but the fifth one is 10. Sixth one I don't know, all the way through the 29th one I don't know, but the 30th one is 110. And since it's arithmetic, we know from term to term we're going to be adding a common difference. So plus D, plus D, plus D, plus D. So when I look at this, I see I am starting with 10. Plus, from the 5th to the 30th term leaves 25 D's in between here. So I am at 10 plus 25 D's will equal the 30th term of 110. So if I solve that, I subtract 10. And I get 25D equals 100. Divide by 25, and I get D equals 4. Well, since it's arithmetic, I know A sub n equals dn plus c, which means A sub n equals 4n plus c. Well, in my n spot, I can put in a 5 or a 30. I'm going to choose to put a 5. So 4 times 5 plus what, which is my c, will equal my fifth term, which is 10. If I continue to solve that, I have 10 equals 20 plus c. Subtract 20, and I get negative 10 equals c. So I can come back here and change this c to a negative 10. And I have my equation. A sub n equals 4n minus 10. We'll do a similar problem with geometric. But the difference is when it is geometric, we multiply. So in this sequence, they gave me the third term is 24 and the eighth term is 5832. So again, I'm going to make myself a picture. First one I don't know, second one I don't know, third one is 24. Fourth one I don't know, fifth one, sixth one, seventh one, but the eighth one I do know is 5832. Well, geometric is multiplying by a ratio. So multiply by r, multiply by r, multiply by r. So in this case, I am starting with 24. 24 times r. Well, from the third to the eighth term is 5 r's. So it is r times r times r times r times r, which means r to the fifth. And that will equal my last term of 5832. So the difference here is that we were multiplying by that many r's, where up here we're adding by that many d's. So when you add, it is times the d. When you multiply, it is the ratio raised to that power. So continue solving this. Divide by 24, and I get r to the fifth equals 243. Now I must fifth root both sides. So I get r equals 3. So I'm going to put it into my geometric equation. A sub n equals first term times ratio raised to the n minus 1. Well, if going forward from here, it meant multiply by 3, multiply by 3. Going backwards, it would mean divide by 3. So to get to this blank, it would be 24 divided by 3, which would be 8. Getting to this one, it would be 8 divided by 3. And I'm going to need you to show that division going backwards if that's the way you're going to use it. So the first term is 8/3 times the ratio is 3 raised to the n minus 1. And I have my equation. Now we're going to look at a few options where we use both the arithmetic and geometric sequence. In this case, it says Jan has a new job. She is paid according to option 1 or option 2. First of all, they want to know which option is the best if she plans on staying at the job for 10 years. And secondly, which is the best option at the breaking point. So let's look at A. Option 1 says beginning salary of $25,000, annual raise of $2,000. So in her first year, she has $25,000. To get to her second year, she would have to add $2,000. Then to her third year, add $2,000. So this is an arithmetic rule. 2,000n, because my difference is 2,000, plus C. So I can put a 1 in the n spot, so I get 2,000 plus what gives me my 25,000. Subtract 2,000. I get 23,000 equals C. So I'm going to come back here and replace this plus C with plus 23,000. And there is my first option's equation. In my second option, it says she gets a beginning salary of $30,000 and an annual raise of 2%. So in the first year, she has $30,000. To get to the second year, we have to multiply by 1.02 because she gets 100% of her money and a raise of 2%. And we keep multiplying by 1.02 to move from year to year to year. So this is geometric, which is A sub n equals first term, which is 30,000, times ratio, which is 1.02, raised to the n minus 1. And there's our option 2 equation. So now, if we go back to the question, it's stated, which option is best for 10 years? So 10 years means I'm going to plug a 10 in the n spot. So let's look at option 1. A sub n will equal 2,000 times 10 plus 23,000. That is 20,000 plus 23,000, which is $43,000 after 10 years. Option 2 would be A sub n equals 30,000 times 1.02 to the 10 minus 1, which is 9. And that gives me 36,569.83 cents. So which option is the best? Clearly, it would be option 1, since she makes more money in 10 years. Now, the second question asks, in how many years will she reach a breaking point? A breaking point is the intersection of the two graphs. So I'm going to put $2,000x plus 23,000 in graph 1 And in graph 2, 30,000 times 1.02 raised to the x minus 1. So if you look at this, you can see in the red graph, I put my 2,000 plus 23,000. In the blue graph, I put my 30,000 times 1.02 to the x minus 1. And the breaking point is where the two intersect. So on your calculators, you would calculate intersect through second, trace, and then choose number 5, intersect. And we see that happens after 4.6 years and at $32,224.61. So the breaking point is 4.6 years at $32,224.61.